Hello class, welcome to the next section in chapter 12. This is 12.4. Today we're going to talk about the mathematics of finance. Now this is obviously an important topic. If you go into a business calc course or applied calculus course, this is a topic that you talk about a lot actually. In a regular calculus 1 class, this is a topic that we don't really talk about too much. It gets glazed over here and there, but it's not a particular topic of focus. So I think it's a good time to talk about this, especially in this point in the section of the textbook. It has to do with a lot of things that you will at some point have to understand in your life, right? So even if you don't use the mathematics at that point because you forgot everything because it's so long ago, at least you'll have a basic understanding of how these things work, right? So we're going to start off by talking about annuities, okay? An annuity is basically something that you are investing in. It can be a savings account, money market account, not necessarily stocks because stocks go up and down, but it could be bonds. Bonds generally have a guaranteed rate of increase, retirement account, trust fund, a mortgage. Even though you are paying into a mortgage and paying interest on it, it is something that is sort of adding to the value of your monetary status, right? So things that are investments basically are an annuity. Okay. The way that we describe an annuity is that you're making regularly scheduled payments into this thing. So it's not like you pay $100 at one point and then $500 on another point and then $300 on another point. It's a steady rate, right? So it's a steady investment, steady amount at a steady interval. Okay. The amount of an annuity is the total amount that you will receive after your last payment. So this includes all the money you've invested from the first payment to the last. It also includes all of the interest applied to your earnings. Okay. We call this total amount AF. A sub F. Okay. I is the interest rate per time period between payments. So if you pay every month, then your interest is being accrued monthly. If you pay once a year, your interest is being accrued once a year, right? So it's the interest rate per time period. R is the amount that you're making into this account. Okay, so R is the regular payment value. So let's take all these things and form an example. So let's say that we deposit $200 every month into a money market account. So money market account, it's like a savings account, earns generally more interest than a savings account. And it's a little bit more volatile, meaning there's a little bit more risk involved because it has a higher return. But we generally invest in money market accounts for short periods of time, right? Unless you're using a money market for retirement, then you're basically you're investing at a high risk rate at that point. Okay, so let's say that you're putting $200 every month into a money market account that has an interest rate of 3% per year, right? So here our interest rate is going to be per month, even though this is the yearly interest rate. Okay, so 200 is going to be our value of R. That's our regularly scheduled payment. Okay, so after the first month, then we're going to have $200, right? Because we're making a payment of $200, and the $200 that we first used to open our account accrued a 3% divided by 12 because it's monthly at this point. So this is the accrual rate for the first $200 that we opened the account with. So it's been sitting there for a month. It accrued some interest, and then we made a second monthly payment that has not accrued any interest yet after the first month. After the second month, we will have that $200 that has sitting there for 2 months. So it has the interest that it's earned plus another set of interest that is earned for the second month. This payment here has now earned 1 month of interest, and we have made a new payment of $200. So I know we're used to looking at our sequences as moving this way, or the series, the partial sums as moving like first value, second value, different, but we're actually going backwards this time. Okay, this is the amount that's been there the longest. It's been there for 2 months. This has been there for 1 month. this is the fresh payment. Okay, and it's going to continue on in that fashion, and we can start to summarize this in this manner, right? So we know how to turn this into a sequence. It's geometric in form because each time we're multiplying by something with a different R value, actually. So we can write the sum as k equals 1 to n of 200 times 1.0025. That's what 0.03 divided by 12 is if you plug this into your calculator. K to the minus 1. So it's a geometric series that follows this formula, okay, for this example. So for 24 payments for 2 years, that's our entire set of payments here. Okay, so after 2 years, this is how much money that we would have. So paying $200 into this money market account that's earning 3% per year. After 2 years, we will have just about $5,000. Okay, so if you think about that versus how much we would have if we just invested $200 period with no interest rate every month, that'd be 200 times 24, which would be 4,800. So we've earned about $140.56 in interest. Okay, so if we kind of summarize this as my payment, and then my payment plus my interest, and then that payment for 2 months that's been sitting in there, or 2 cycles, is squared, and so forth and so forth. Right. So if we summarize this, we know that the sum, right, of all of these things has a formula to it. It's 1 minus that R. In this case, R is 1 plus I, 1 plus that interest rate. So if we plug that into our formula, this is the total amount of the annuity. Okay, so we can simplify this on the bottom because we distribute this negative across. So then the ones cancel, and it's really just negative I, right? So if R is the regular payment amount to an annuity that gains an interest amount of I per payment period for n payments, then the final amount of the annuity is given by this formula. Okay, so what I did here was I took this negative value, and I applied it to the numerator. So that's why it switched order here. Okay, remember, I is your interest rate. I is not the complex letter I. This is not an imaginary number. Okay, the next thing we're going to talk about is the present value of an annuity. So present value is a little bit different. It's kind of like saying how much would I have to pay right now into this annuity, right, into the savings that I have, in order to only have to put in this much per month to have this much after this amount of time. Okay, so another way of thinking about that is kind of like a good example is the lottery, right? Would it be more beneficial for me? How much would I need to have right now altogether if I won the lottery to have the same amount as if I were to be paid in installments where they're taking out a certain percentage in interest, right? How much would it be to just cash me out? That's why when they say, oh, you won $1 million in the lotto, and they're like, but if you cash out right now, you're only going to get $700,000, right? And that's because the present value of that is $700,000. That's one way to look at the present value. Another way to think about it in terms of an investment is, if I only want to invest for 3 years, how much would I have to invest now so that I'm making payments, for 3 years, but I would save the same amount of money as if I was only making payments for 10 years. Okay, so it's a little awkward, the phrasing of this, until I actually put something on paper, right? So that's just me trying to talk through it for you guys so you can understand a little bit. But present value is the amount of money that if I were to invest it today, right, like literally right now, at a rate of I per payment period for n payment periods, right? So let's say for 5 years, where it's like 2% per year or something like that, or 1.5% per month, that it would equal to the final amount. Okay, so for example, say instead of investing $200 a month, like I did in the previous case for 2 years, we only wanted to know how much money we could invest and let sit and earn the same amount of money in interest in 2 years that we would by making annuity payments. So let's say instead of paying into this every month, I just put one lump sum and I sit and I let it gather interest, right? So without me making payments into this account, and I just put one lump sum and let it sit and accrue interest, how much do I have to do that so I still have the same amount in 2 years as I would if I was paying in $200 every month for 2 years? Okay, so that's the present value, which we call AP. It's the amount I would need for this investment. So for our previous example, this was the amount that I had, AF, right, after my 2 years. So this would be the formula. I would put in just one big lump sum. I would get 3% divided by 12 for 24 months. This would be the formula I would need, and I basically just solve for AP. So solving for AP, I move everything aside. If I invested $4,653.19 and I just let it sit in an account that earned 3% per year, I would have the same exact amount of money as if I invested $200 that earned interest every month. Okay. So again, AP is my final amount of the annuity divided by that interest rate for end payments. So substituting in the formula for AF, we have the following. Okay. And generally, I'm either interested in R, the number of payments I would need, the amount of payments, or I can just simplify this to get my AP formula. So in order to get AP, I can simplify this by multiplying by the reciprocal here, and I get this formula. From here, I can separate this into 2 halves, right? I have 1 plus I over n over 1 plus I over n, so that leaves me with 1 over I. And this is just 1 over I plus in. Okay, so I can clear out my denominators here. I'm sorry, add my fractions basically, and pull out this common I. So I have R over I. That leaves me with a 1 here, and this turns into 1 over 1 plus I to the negative n because it's in the denominator. Installment buying. Okay, so installment buying is basically us taking this formula here and solving for R. It's basically if I want to take a loan for a certain amount of money, how much are my payments going to be, right? So we're taking out a loan. The amount of the loan is this AP, right? I'm taking out a certain amount, but obviously my final payment on that, I'm going to be paying more because of the interest accrued. So when I take out a loan, it's an AP, right? It's not an AF. It's not a final value of an annuity, right? It is this AP value, okay? This present value. So if I take out a loan, that's the value AP, right? The regular payment amount on that loan over n payments is given by this formula, right? I basically just take this formula and I solve for R. It's the same formula used before. Again, this is like if you're taking out a loan on a car, a mortgage payment, a loan, right? A loan on a house. It's the same kind of thing. You take the amount of your loan times the interest rate per payment period, and then you plug everything else into here, and that'll give you your rate. So let's do an example. So let's say we took out a car loan for an amount of $6,000 that has a yearly interest rate of 10% on a monthly payment schedule for 5 years. That's pretty standard for a used car, right? A brand new car, this would be more like 40 grand, right? 30 grand. So let's say 6 grand. You can also think about this as like a student loan payment, right? A student loan, generally each loan is around $6,000 to $8,000, and then you end up doing that every year, so that kind of grows pretty quick, right? So we want to know what our monthly bill is going to be if we're going to borrow $6,000 at this interest rate on a 5-year plan, or a 60-month plan generally is what they call it. Okay, so I just take all my things and I plug it in. My loan amount is $6,000. I have 10%, but it's monthly. 12 years means 60 payments. So I plug everything into my formula, and what I'm going to get out is how much my monthly payments are going to be, which is $127.48.